Okay, so this is section 2 of the review. We're going to talk about how to convert from grams to moles and vice versa. So let's say you're in a lab and you have a sample, you put it on the scale, and it's 13.8 grams of, let's do H2O. Keep it simple for the example. Okay, now, if you remember, and this is something I've mentioned in class a lot to you guys, grams are what you measure in, but moles are the important unit in chemistry. And we're going to learn a lot more about why later on in the year. So we're going to convert 13.8 grams of H2O to moles of H2O, which you can abbreviate with just MOL. All right, so this is just going to be a simple one-step dimensional analysis. So first thing you're going to do, like you would with any dimensional analysis, write down what you got, 13.8 grams of H2O. And I put it over 1 just so it's a fraction. And then we're going to multiply by some conversion factor. All right. Typically when I do this, I like to write in units before I put in any numbers. So since we have grams up top, up here, we have grams up top. Let me fix that. Then that means we're going to need grams down at the bottom in order to cancel it out. So those are going to cancel. And we're trying to find moles, so I'm going to put moles up here. So we're going to end up with moles. So I got my units good. Now I just need to figure out how many grams, or what's the ratio of grams to moles here. What's the ratio of grams to moles so that we can figure out our conversion factor. Now if you remember, in the last problem, we remembered that we calculated that the molar mass of water, I'm going to write it, molar mass of H2O is 18.02 grams per mole. Now I told you guys there's a reason for molar mass and there's a reason for using that different unit. And this is the reason. Grams per mole works out really nicely because that's a perfect conversion factor to use right here. Okay? So what that number tells us is there are 18.02 grams in 1 mole of H2O. And there's a different conversion factor for each substance, and that conversion factor is just your molar mass. So put that right in the calculator and you're going to get 13.8 divided by 18.02. Okay, straight in the calculator that's 0.7658, blah, 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 so on. All right. Now, if you look back at our answer, there are 1, 2, 3 sig figs. So our answer needs to be 1, 2, 3 sig figs. So we're going to end up with 0.766 moles of H2O. All right, that's what we got, 0.766 moles of H2O. So let's do one more. Tell you what. So that's how you do grams to moles. The other thing that you can have is moles to grams. So let's say in a problem you were told that you have 1.253 moles of, let's just say, sodium chloride. So you have 1.253 moles of sodium chloride, and you need to find out the mass, how many grams of sodium chloride. Okay, so this is what you're given. So just like we did before, and I'm going to extend here, just like we did before, first step, we write down what we got, 1.253 moles of NaCl. All right, put it over 1, set up our dimensional analysis. So this time, let's look at units. We got moles up here, so we're going to need moles down here to cancel out. Let's get rid of those. Okay, we are converting 2 grams, so grams will go up here. All right, so our conversion factor for grams to moles, again, is going to be molar mass. So let's do that over here. So we're finding the molar mass of NaCl over here. So mass of Na, and you definitely do not need to write all this. Once you get good at it, you don't need to do it in such long terms, but I'm just writing it out so you can see what I'm doing. So the mass of Na is 22.99. Okay. Mass of Cl is 35.45 AMU. Add those together. Let me put this in my calculator really quick. And you're going to get 58.44 AMU. Now, for molar mass, again, we just convert it to grams per mole. Okay. Now, we put that in our equation that we were using earlier, our dimensional analysis. So since grams are on top, we're going to do 58.44 grams in 1 mole. Put that in your calculator and you get we'll see. Hang on. 73.23 with the right number of sig figs, and that is grams. Okay, so if you look back, whether you're going from grams to moles like we did up here, or from moles to grams like we did down here, you're really just doing the same thing, right? You're just doing a one-step dimensional analysis. The only difference is you reverse your conversion factors, right? And it just depends on what units you need to cancel out. Just like with any dimensional analysis, you just arrange it so that the right units will cancel out, okay? So let me give you guys a couple examples. Let me give you guys a couple of examples of some conversions. So let's do 174.5 grams of PbNO3 to moles. And I'll do another one over here. We're going to do 1.01 moles of in sodium hydroxide, NaOH, and we're going to convert that to grams. All right, go ahead and pause it, solve both problems, and then unpause it, and you can look at the solutions when you're done. Okay, so let's do lead nitrate first. So we're going to set it up, 174.5 grams of lead. This is lead 1 nitrate. Okay. Multiply by our conversion factor. Grams are going to need to be on the bottom, moles on top to get the cancellation right. Okay. Now we just need to find our molar mass of lead nitrate. So let's do that right here. Okay. We have mass of Pb is 207.2. Mass of nitrogen, which there is one of, 14.01. Mass of oxygen, 16, and there are 3 of them, so we end up with 48. Add all of these numbers together. I'm going to use my calculator for this. My middle school teacher used to tell me, using calculators rots your brain. Oh well. So the mass of our whole compound, our molar mass, is 269.21 grams per mole. Okay. So that is our molar mass. Okay. So let's put that straight into the formula that we were using earlier. 269.21 grams in 1 mole. Okay, and you should get, I'm going to go down a little bit, 0.64, how many sig figs do we have? 4 sig figs? 0.6482 moles. So there's your answer. All right, let's do the other one. So if we have 1.01 moles NaOH, multiply by our conversion factor. Moles have to go on the bottom, grams on top. Okay, so again, let's find the molar mass. So I'm gonna shortcut it here a little bit. Now that we're getting used to this, we don't need to really write it out as much. So the molar mass of Na, 22.99, plus the molar mass of oxygen, plus the molar mass of hydrogen. So add that all together, and it looks like it's just going to be 40. And again, we're going to use 3 sig figs because hydrogen was 3 sig figs. Okay, so let's plug that straight in. We had 40 grams in 1 mole of NaOH. I'm sorry. So we're going to do 1.01 times 40, and we get 40.4. Okay, so your answer is going to be 40. That's a terrible 4. 40.4 grams. All right, so we are good on that. And I want to go over the one other thing that you might see when it comes to conversions between grams and moles. So what if I told you you have, let's keep it simple, 2 moles of, let's just do SO2, sulfur dioxide. 2 moles of SO2. And I asked you, how many, not atoms, how many molecules is that? How many molecules of Cl2 if you have 2 moles? So a lot of times when people look at this, it's just kind of a mind blower right off the bat because we haven't talked a whole lot about molecules and things like that. But this is really an easy problem, and you're going to do it the same way that you basically just did grams to moles. So let's go ahead and set it up. We have 2 moles of SO2. All right. So moles down here, molecules up here. Moles are going to cancel. All right. So now is where we get to the question. What is the conversion factor from moles to molecules? Okay? What is that conversion factor? Well, if you remember, 1 mole, and this is a definition of a mole. This is what a mole is. 6.022 times 10 to the 23. That's what a mole is. Just like I would say 1 dozen equals 12. Okay, I'd say 1 mole equals 6.022 times 10 to the 23. That is a 0 here. So whether it's molecules or whatever you're counting here, this is what you can use. So in 1 mole, you have 6.022 times 10 to the 23 molecules. So basically, if you have 2 moles of something, you're going to have 2 times 6.022 times 10. I don't even know where this is on my calculator, to the 23. All right. Punch that in. You should get 1.2, and I only used 1 sig fig. I shouldn't have done that. Let's pretend I said 2.0 moles. So it's going to be 1.2 times 10 to the 24 molecules. Okay? So that's all you got to do. 1 mole equals 6.022 times 10 to the 23. So I'm going to give you guys one more sample problem, and then we're going to be done for this section. So let's say you have, let's go down a little more. Let's say you have 6.053 grams of, let's do water. I like keeping it simple. And I ask you, well, how many water molecules is that? So there's your givens. So we know this is going to be a dimensional analysis. 6.053 grams of H2O. Okay? So we know for a fact grams has to go here in order to cancel. Can we convert grams to molecules? Does that happen? Okay, it doesn't. But we do know how to convert grams to moles, and we know how to convert moles to molecules. So this is just going to be a two-step deal. Okay? Moles are going to need to go on the bottom, and molecules on the top. Okay? So we have the conversion factors to do this here. Okay, so in 1 mole of water, you have 18.02 grams. We've calculated that several times by now. And in 1 mole of anything, you have 6.022 times 10 to the 23 molecules. So this is all you got to do to find a two-step problem like this. So it's going to be 6.053 divided by 18.02 times 6.022 times 10 to the 23. And your final answer for this problem should be 2.023 times 10 to the 23 molecules. All right, that is it for the grams to moles and other conversions section. So I would advise you to try the problems on the study guide.